so first question we're going to look at is for an ellipse, and it's finding the equation. So the first thing we want to do is see if we can identify the center, because that's missing, and then we can figure out our A, B, and C. Okay, so with the information they've given us, we can figure out the center. If we have vertices that are +6 and -6, the center has to be exactly halfway between the two. So where would that mean the center has to be?
0, 0?
Yeah, so even though they didn't tell us that, we can kind of infer that that's where it has to be. So we've got the center, and which one of these pieces of information is going to help us to find A?
The vertices.
Yep, the vertices. How far is each vertex from the center?
6.
6. So that's our A. B we're not going to be able to do directly. We're going to have to use a formula for that one. But C we can do. How far is the center from each focus?
4.
4. And now there's a formula that will connect A, B, and C so we can solve for B. Do you remember the formula for an ellipse that connects those?
C squared equals A squared minus B squared?
Minus B squared. Yep. So C squared is 16, and A squared?
36.
36. And if we subtract 36 to the other side, we're going to get negative 20 equals negative B squared. So we cancel the negative on each side, and that means B is how much?
2 root 5.
Would be square root of 20, which is 2 root 5. Yep. Okay, so we've got A, B, and C. Now we need to write the equation. When you write the equation of an ellipse, it's always equal to what number?
1.
Always equal to 1. We're going to have two fractions. What symbol goes between them? Plus or minus?
Plus.
For an ellipse, it's plus. Okay, and now we have to figure out x squared and y squared, but for an ellipse, you always put x squared first, and you always put y squared second. That never changes. What changes in an ellipse is where we put the A and the B. If you were to graph these points, how would they line up? Vertically or horizontally?
Vertically.
Yeah, it would line up vertically, because our vertices are up 6, down 6, up 4, down 4 for the foci. That means we want the major axis to go vertical, which means what is going to go under the y squared?
36 or
36.
6 squared.
Yep. So we want the bigger number under y, that makes it go vertical. And what are we going to put under x squared?
20.
20. That's b squared. And that is the equation of your ellipse. Okay. Any question on that one? Okay, so for the next question, we're going to find the equation of the ellipse. So there's some extra points on here we don't need. So don't focus on, I think that's probably one of the foci. We don't have to worry about that for the ellipse, and you also don't have to worry about that. Okay. For an ellipse, all we need is the A and the B to make our equation. What does A measure? The distance between what and what?
The center and the vertices.
Center and the vertices. So that is A. So this point, got a little bit cut off, is 4, 2. This point is 1, 2. How far apart are 1, 2 and 4, 2?
3.
Yep. So we got our three units there. And what does B measure on an ellipse?
The center to the minor axis.
Yeah, the center to where it would hit a minor axis. So that's B. So that is, well, let's look at this one because it didn't get cut off. 1, 2 up to 1, 4. how many units is that?
2.
Yeah, 2 units. Okay, so we've got A, we've got B. We don't need C, but the other 2 letters we need, H and K. H and K are the coordinates of the what?
The point, the center,
The center, yeah. And what's the center of that ellipse?
1, 2.
1, 2, yep. All right, that's all the letters we need to write the equation. So now, we're just gonna make sure we set it up right. So we're gonna have equals 1. We've got 2 fractions, plus sign between them. What do we want? We don't even have to think about the A and the B yet. What letter always goes in the upper left part?
An X.
Yeah, so we always want X, and in this case, because we've shifted it, what would I need in parentheses with it?
-1.
Yep, so X minus 1. And what about your next numerator?
Y.
Y
-2.
minus 2. All right, now we do have to think about where we put the A squared and the B squared. We want the bigger number under which letter, X or Y?
Y.
Um,
Oh, wait, no, X.
so yeah, this way is, let's see, that's 3 units long. It's 2 units for the B. So we want the ellipse to be the long way to be horizontal. So yeah, we want the bigger number under X. So between these 2, the bigger number is 3. So that means underneath X you put
9.
9, and underneath Y,
4.
4. Perfect. And that's the equation of your ellipse. Any question on that one? And okay, so this one, a little bit different than the last 2. I'm going to give you the equation, and then I want to figure out all the important facts about it. Okay, so first thing you want to do off to the side is identify A, B, and C. Which number here is going to help you find A?
64.
Yep, so we want to look at the 64, but that's A squared. So A would be
8.
8. And the 9 is going to help you to figure out
B.
B. So that's B squared. So B would be
3.
3. And now the last thing we need is C, and we do need it because they want to know the foci. So the formula, C squared equals A squared minus B squared. Should have checked this before I made it up. But yeah, no, we're fine. Yeah, we're fine. So C squared equals 64 minus 9, which means C is the square root of how much?
Square root of 55.
Yep. So square root of 55. Okay. All right, so now we're ready to start to figure out what's going on. Okay, where is the center of this ellipse?
0, 0.
Yeah. Until you see adding and subtracting in the numerators, you don't have to worry about shifting the center. Okay. Next thing we need to figure out is the direction of the major axis. Is it horizontal or vertical?
Vertical.
Yeah, because the bigger number is under Y. Now that we know it's vertical, everything is above and below the center. So what would be the coordinates of your vertices?
0, 8, plus or minus.
Yep, so 0 plus or minus 8. And the coordinates of your foci.
0 plus or minus square root of 55.
Yep. And that would be all the important things I would ask you to describe for an ellipse. Any question on that? Okay. All right, so now we're going to look at hyperbolas. So we've got a picture of a hyperbola, and we want to find the equation for it. Well, first thing we want to figure out is the center. Where does it look like the center of this hyperbola is?
0, 0.
Yeah, 0, 0, because if you look at the two vertices, negative 4, 0 and 4, 0, find the midpoint of them. It's 0, 0. So you don't have to worry about H and K. But we do need A, B, and C. Okay, so A is the distance between the center and the vertex, and you have both vertices labeled. What's the distance between the center and the vertex?
4.
4 units. Okay, so we've got A. B we're not going to be able to get. We don't have anything visual to help us with that. But we do know where each focus is. What's the distance between the center and focus?
5.
5. Okay, so we've got A, we've got C, but to write the equation we need B. So what's the connection between A, B, and C for a hyperbola?
C squared equals B squared minus, no, plus
Plus.
A squared.
So C squared equals A squared plus B squared. So we're going to get 25 equals 16 plus B squared. 25 minus 16 gives me 9, which means B will come out to 3. Okay, so now we've got A, B, and C. We just have to fill them into the formula. Okay, for a hyperbola, it's always equal to what number?
1.
Yep, always equal to 1. Two fractions. What goes between the two?
Minus.
We've got a minus. What is always your first denominator? A squared. And your second denominator?
B squared.
B squared. Okay, so the only thing we got to figure out is where the x and the y go. But that's going to be squared, and that's squared. Which way does the transverse axis go?
Horizontal.
Goes horizontal, which means you want which letter to be the one that's in front to make it positive.
X.
Yeah. You want x in front, and you want the negative in front of the y. And that's the equation of that hyperbola. Any question on that? Okay. All right, so next one we're going to take a look at is discussing this equation. So this is a hyperbola because it has the minus sign in between, and each letter is squared. Okay. What, out of the 5 letters on the side, which one could we find first pretty quick?
The H and the K.
Yeah, what's the H going to be?
2.
H is going to be 2, because that's the number after the minus. And what about the K?
Negative 3.
Yes. So you're going to be careful there because it was changed to a plus, but yep, it's negative 3. How about A?
2.
A is going to be, yes, 2. And B?
5.
5. And the formula to get C?
C squared equals A squared plus 5, no, B squared.
Yep. So we're going to get C squared equals 25 plus 4, which is 29, which means C is?
Square root 29.
Square root 29. Okay, so now we got everything we need. Let's write it out. What are the coordinates of your center?
2, negative 3.
2, negative 3. Yeah. Okay, let's do the, you know what, let's do the transverse axis next.
Horizontal.
This is horizontal. Yeah. Now we know everything is left and right of the center. Okay, the vertices are 2 units left and right of the center. You can't use plus or minus here. We're going to have to write them separate. So what would be 2 units left of the center?
0, 3.
0,
Negative
negative 3. And 2 units right of the center?
4, negative 3.
4, negative 3. Perfect. And what about for my foci?
Square root of 29 plus 2, negative 3.
All right, so we've got square root of 29. How did you say that one?
Square root of 29 plus 2, negative 3.
Okay, I'm just gonna, yeah, so I'm gonna write it as 2, and then I'm gonna shift it square root 29 to the right. And then I want to think of it as 2 shift, yeah, minus square root 29. So 2 plus and 2 minus, shifting it. And asymptotes. What is the formula for the slope when the transverse axis is horizontal?
H equals B over A.
Yep, B over A. So the slope is going to be what?
X equals 5 plus or minus 5 over 2x.
So plus or minus 5 over 2x. Now that's only the slope. We need point slope form because it's not at the origin. So we're going to have y minus something equals m times x minus something. Y minus, usually you put y1 there. What's the y value that this point, or that this line is going to go through?
2.
That's the x value it's going to go through.
Oh, -3.
Yes. That's the point your line has to go through. So y minus y1. And what are we going to put over here?
3. Oh, the x values. 2.
2. So that's the point that it goes through, 2, -3, and that's its slope, b over a. Okay, so that one had a lot. That one had everything you could possibly have in a hyperbola to discuss. Okay, any questions on how to find any of those? Okay. All right, so the last conic section problem will be finding the equation of this, and I do need to tell you what it is. It is a hyperbola. Well, technically, if I want it to be tricky, I don't need to tell you that it's a hyperbola, because if you know about hyperbolas and ellipses, in a hyperbola, the foci are always further away. So I would tell you it's a hyperbola, but you kind of should be able to figure it out based on that information too. Okay, so let's find A, B, and C. What can we find right away?
A and C.
Yep, what's A going to be?
3.
Right, and C?
5.
5. And now we have to figure out B. So how do we get B using A and C?
C squared equals A squared plus 5 squared.
So C squared equals A squared. And what did you say comes next?
Plus B squared.
Plus B squared. Okay. All right, so when we solve for B, what are we going to get?
Square root of 16 or 4.
Yep, so we get 4. All right, so now let's write our equation. Fraction. All right, so you go ahead and you tell me what we need.
It's going to be x squared on top of the first equation.
So which
No,
way
y
does
squared.
our transverse axis go?
Vertical.
Vertical.
Y squared is first. And then the second numerator is going to be x squared. And then a squared always comes first, so that's 9. And then b squared under x squared, which is 16.
Yep. So that's the equation of the hyperbola that fits those characteristics. Any question on that one? All right, the next question is solving this system graphically. When we graph a system and we're looking for the solution, what are we looking for on the screen?
The points where the lines cross.
Right, we're looking for the intersection points, whether it's 1, 2, 3, just looking for where they cross. This one's okay to type in the way it is, but this one is not. What do I have to do to that top one so I can type it in on the calculator?
Write it into y equals mx plus b.
Yep.
So divide by 2.
And if you divide everything by 2, what would that give you?
Y equals 3 over 2x plus 4.
Yep, and just so I can avoid a fraction, but it doesn't really matter. It's 1.5x plus 4. Okay, so I've already typed both of those in. 1.5x, whoops, I changed that to a 3. So we've got our two equations typed in. Hit graph. And how many solutions does it look like we have?
2.
Yep. And how would you find each one of them on the calculator?
Is it second calc and then intersect?
Yep, second calc intersect. And let's say the question I gave you said to find the solution in quadrant 1. Right, focus just on the solution in quadrant 1. So you'd be looking for that answer right there. 2, 7. May or may not come out to nice numbers on the test. Just got lucky with the numbers I picked. It came out very nice. Okay, so any question on what you're looking for when you solve graphically? All right, so next question we're going to look at, this is a system we're going to be solving. It's a 3 variable, and we're going to figure out, first thing we have to figure out is what letters we want to use to represent our 3 numbers. So what do we want to use?
X, Y, and Z.
X, Y, and Z. Okay. So we're going to look at it sentence by sentence and translate each sentence into an equation. If you use X, Y, and Z, how would you write that first sentence?
X minus Y plus 5Z minus, no, equals 24? Negative 24?
So now, are you doing this one?
Oh, no.
Okay. We could do the second one first, but let's start with the first one first.
X plus Y plus Z is 4.
Okay, so there's your first equation. And what did you say your second one again?
X minus Y plus 5Z equals negative 24.
Negative 24. And now the third sentence, let's do that off to the side because it's not in the right order. But let's do it in the order they give us first.
Okay, so Z plus 5 X plus Y equals 24.
Okay. And if we put that in the correct order, so the order that matches what we already have, it would be
5X plus Y plus Z equals 24.
okay. Now, based on what we have, there is a letter we could pretty easily eliminate and not even have to multiply equations by anything. What letter could we try to eliminate?
X or Y.
Yeah, I would do Y because we already have a negative 1Y and a positive 1Y. So we can just combine them and they'll just cancel out. So let's eliminate Y. In what 2 equations do you want to do first?
2 and 3.
2 and 3, okay. All right, so we're going to eliminate Y in 2 and 3. So X minus Y plus 5Z equals negative 24. 5X plus Y plus Z equals 24. And we don't even have to multiply by anything. So if we add the X column, what will you get there?
6X
And the Y column,
cancels.
that's gone. And the Z column.
6Z.
And the numbers on the other side?
0.
Okay. So we get 6x plus 6z equals 0. And you can make that a little simpler by dividing everything by?
0.
No, can never divide by 0.
Oh, 6.
Divide everything by 6. So there's a new equation. Let's call that equation 4. Now we've got to eliminate the same letter again, but you can't use 2 and 3. So pick 2 different equations to eliminate y?
1 and 2.
1 and 2. Okay, so let's write down 1 and 2. X plus y plus z. There's 1. And x minus y plus z. Okay, if we do this right, we're going to end up with another equation with x and z, and then we'll go from there. Okay, so add your x's, and what do you get?
2x.
2x. How about when you add the y's?
Cancels.
That's gone. And the z's?
6z.
6z. And the numbers on the other side?
20.
20. And we can do the same thing we did last time. We can make all those numbers a little smaller by
Dividing by 2.
dividing by 2. X plus 3z equals 10. Okay, that will be equation 5. Now we're going to take 4 and 5 and figure out how we can eliminate another letter. Okay, so now we don't have a choice. You have to use 4 and 5, but do you want to eliminate x or z?
X.
Eliminate x. So we're going to eliminate x in 4 and 5. Okay, this time, if you combine them just the way they are, will the x's cancel?
No.
No. So this time we're going to have to multiply. Okay, you can pick either equation and then just tell me what number you want to multiply it by.
The top one by -3.
Top one by...
Actually, -1.
Yeah, if you're going to eliminate
Yeah.
x, yeah, you want to go with -1. Okay. If you multiply the top by -1, what does that give you?
The x's cancel. Oh, for that one. -x minus z equals 0.
Okay, yep, very good. And the bottom one, what's happening to that?
It stays the same.
Yep, perfect, stays the same. All right, now when we add them up, what happens?
The x's cancel.
X's cancel.
And then you get -2z. Oh, no, +2.
Positive 2z.
And then equals 10.
It's 10.
And then you divide and you get z equals 5.
Okay, so there's our first answer. We got z equals 5. Now, what would be the next letter we could find?
We could find x.
Yep, I would find x, and we could plug back into equations 4 or 5. I would probably do 4.
Yeah.
So you got x plus 5 equals 0, which means x is,
-5.
and we're done x. And the last letter we need to find?
Y.
Y. Okay, so we're gonna go all the way back. Probably the top one.
Yeah.
X plus y plus z equals 4. Alright, so we got x plus y plus z equals 4. Except we fill in z. Okay. So what's going to happen there?
The 2 5s are going to cancel. And you're just going to have y equals 4.
Yeah. Okay, so that was a very nice system. Everything worked out, no decimals, things just canceled. It's about as nice of a flowing problem as you're probably ever going to get. Yeah. Sometimes it's not that nice. Any questions on that one? Okay. All right, so next one we're going to look at is solving a 2-variable system. And you could choose elimination or substitution, but I think this one is set up for one of those methods better than the other. Which one do you think this is set up for?
Substitution.
Yep, set up for substitution because we already have one of the variables by itself. So we know y equals 2x minus 1. And what are we going to do with that?
Plug it into the y in the second equation.
Plug it in for y in the second equation. Perfect. when we plug it in, we want to be careful because that 3 is going to turn into a what property?
Distributive.
It's going to be distributive. So when you substitute, make sure you put it in parentheses. Okay, so we've got 2x plus 3 times 2x minus 1 equals negative 7. All right, what do I get when I distribute the 3?
6x minus 3.
6x minus 3. All right, what's going to happen next?
You can combine like terms and get 8x. You can subtract 3 from both sides.
So we got 8x, and what are you going to do with the 3?
Add 3 to both sides. And then you get negative 4.
So we get negative 4.
And you can divide by 8, and it'll be x equals negative 1/2.
Negative 1/2. So we got a fraction, but it's not an awful fraction to work with. So we got x is negative 1/2. Now what do we have to do?
You have to plug that into the top equation.
Yep. Technically, you can plug it back into either one, but I think the top is much faster. So if we fill that back in, we get y equals 2 times x, which is negative 1/2, minus 1. What's 2 times negative 1/2?
Negative 1.
Negative 1, and negative 1 minus 1.
0. Negative 2.
Negative 2. Yes. So y equals negative 2. All right. Any question on that one?